So Monday I'm going to give you Einstein Competition, right? Today, right now, I'm going to go over some of the problems that we see on Monday. So let's get it started. So the problem, oh wow, very good. Einstein Competition 1, very nice, thank you. And that's card number 1. About the same card, the card moves to the west, right? T initial is 0, T final is also 0, V initial is 0, and V final is also 0. How many graphs you're going to make? 1, 2, 3, 4, 5, and 6.
Sorry.
We're going to call it dt. We're going to call it displacement versus time. We're going to call it st. We're going to call it vt. We're going to call it at. We're going to call it at. So make it a little different. Then so you want to use the different color, and you okay, listen.
Yep.
You're not only gonna draw the graph, but also you're gonna write 6 equations. Good luck.
Alright, so here's the thing. The car never really moved in the first place. Why? Because we're assuming linear acceleration here. I mean, the initial velocity was 0, and the final velocity was also 0. So if there was linear acceleration, that means the car never even gained any velocity to start with. So the distance and displacement graphs are also 0, which means that all of these functions are actually the same exact thing. Zero.
All right. Can I change the scenario now?
Yep.
10 meter per second, and this one is 10 meter per second, and of course I'm gonna erase it and this the distance versus time. Okay.
We can tell that the velocity stays completely the same, just like the previous scenario, but this time it's actually not at rest. But that doesn't matter for us because we know that the acceleration is completely 0. It just stays constant. And for the velocity and speed, it stays constant, but it has a vertical shift because it actually has some velocity now instead of being at rest. So for speed, it's always going to be constantly at 10. And for velocity, since you can tell it's going in the negative x direction, we're going to extend the graph down here, and it's going to be at minus 10. All right, so what about distance and displacement? Well, since velocity is always the same, it's going to increase linearly. So it starts at 0, stops at, wait, t final equals.
Oh no, T final is not 0. Very good. T final is, let's say, 2 seconds.
Oh, ouch. Sorry. So stops at 2 seconds, and Vf is 10, which means that in this time of 2 seconds, since it's at constant velocity, traveled a total of 20 meters. So it's going to look like a line, like this. And displacement, we have to take account of the direction. So since this is going in the negative x direction, it's going to look like this, pointing downwards. So this is 2, and this is negative 20. So now expressing all of these as functions, d of t is 10t. Displacement of time is minus 10t.
Write it below the graph, otherwise it's gonna mix up.
Displacement over time is minus 10t. Speed over time is 10. Velocity over time is minus 10. Acceleration over time, well, the magnitude of acceleration over time is 0, which is the same as the actual acceleration over time.
Answer 20 meters per second. And it must 2 seconds, or I don't know, 3 seconds, 4 seconds. Doesn't really matter. 1, graph 1, okay. Graph 2, graph 3, graph 4, graph 5, of 6.
We already know that acceleration, since it's linear, is just going to be the total change in velocity over the total change in time. So it's going to be divided by 4 minus 0, and the numerator is just going to be 20 minus 0, which just gives us 5 meters per second squared, which means it's going to be constant. And since it's accelerating in the negative x direction, that means we can draw it like this, and the time doesn't matter. And of course, since we're taking the absolute value, it's going to be positive over here. So velocity over time is going to start at 0 and accelerate to minus 20. And of course, it's going to have a slope of the acceleration, which is minus 5. So v of t is minus 5t. And of course, acceleration's absolute value is 5. Meanwhile, actual acceleration is minus 5. And over here, speed is just going to be, okay, and we'll draw that. S of t is equal to 5t. And finally, we have distance and displacement over time. Since the velocity is increasing linearly, these have to increase quadratically. But what's the quadratic coefficient going to be? Well, we know it starts at 0, so nothing, no constant term.
Use d is equal to VAT plus half AT squared because they have to use that equation.
So we know d is equal to VIT plus half AT squared. We know since there's no v initial, it's at rest at the start, there's not going to be any first degree term. So it's just going to be reduced to half times acceleration, which was 20 over 4 is 5, times t squared. So that gives us 2.5 t squared. So what's the final answer going to be?
They usually that coefficient in fraction.
Okay, or 5 over 2t squared. So what's the answer going to be? D of t is 5 over 2t squared. And what's the final value? Well, it's 5 over 2 times 4 squared, which is going to be 40. And the same thing for displacement, except it's negative, which gives us displacement over time is minus 5 over 2t squared. Okay, and good luck with the Einstein competition.